Hi there, thanks for tuning into this video. Right now I'm going to be talking a bit about what are polynomials. Okay, so we just learned a bit about what functions are, right? We learned that functions have exactly one input value to one output value. So for example, if we have a line like this, we can tell if it's a function by doing our vertical line test, right? If we had a vertical line that we started on the left and we moved it across, right, from left to right, if this line here ever touched this curve multiple times, we know it's not a function. So this is a function because if we move the line from the left to the right, straight up and down, it only touches that line once for every x value. Okay, so the y value might be the same, like for example, it's the same like kind of along this line right here and right here, but its x values are different. Okay, so that's the main kind of idea with functions. But now that we know what functions are, now we can kind of dive into the idea that there are different functions that we can work with. So there's things like radical functions, for example. So y equals like the square root of x. So if you plotted this on a set of axes, right? This was your y and this was your x. Your output y would just be the square root of whatever your input was. So you'll find when you look this graph up, when you graph it, it's going to be like kind of a curve like this. Okay, so this is a radical function. Okay, you might be dealing with something like a rational function. So y equals 1 divided by x, where x is on the denominator of the fraction. And this is kind of a funky looking one. It's going to look like this when you graph it. Kind of two weird curves going in opposite directions, okay? So there's different types of functions that we can work with, and in this video I'm going to focus on polynomial functions. Okay, so for polynomial functions, an example would be y equals x plus 3. Okay, so there's nothing weird going on. The exponent on this x is a 1, which is a whole number. Okay, so with polynomials, we're dealing with whole number exponents that aren't negative. So if your function was y equals x to the negative 2 plus 3, this wouldn't be a polynomial because negative 2 isn't a positive whole exponent, because we could rewrite this, if you know your exponent laws, as 1 divided by x squared. And anytime we have our variable on the bottom of a fraction, that's called a rational function. That's not a polynomial function, okay? So 1 over x squared, that's going to look like this. Okay, that is not a polynomial function. So anytime variable's on the bottom, it's rational, and that's not polynomial. Some other examples might be, I'll go 3x to the power of 2 minus x plus 1. So this is also a polynomial function. Okay, so the exponent on the x here is 2. There's an imaginary exponent of 1 on this x, and there's just a constant 1. And this 3 in front of the x squared, that's called a coefficient. Okay, so you spell it C-O-E-F-F-I-C-I-E-N-T. Coefficient, that's basically just the number that's multiplying into the variable x squared there. Okay, so that's the coefficient. The exponent is just the value that the variable is being raised to. So in y equals 5x to the power of 3, the coefficient would be 5, that number in front of the x, our variable, and the exponent would be 3 because it's just kind of in the top right-hand corner above our exponent. Okay, so now that we kind of know the rules for what polynomials are, let's get into some examples here. Let's really test your knowledge. Which equations here are going to be polynomials? Okay, so let's go to this first one. So in this first one, we're dealing with y equals the square root of x plus 1. Okay, so this plus 1 I'm not too worried about, because with polynomials, we can just have numbers like 1 and negative 3 and 10. Those are all constants, so those aren't changing, and those are okay in polynomials. But What I'm really concerned about is this root x here, because you'll learn later on the square root of x can be written as x to the power of 1 over 2, and 1 over 2 isn't a whole number. Okay, so even though it's positive, it's not a whole number, and this is going to be called something called a radical equation. So it's not a polynomial equation because we have this square root in there, so that is not good. Okay, so if we have a square root in our equation, that means it's not a polynomial equation. Okay, let's move down to f of x equals 1. Okay, so let's think about how this would look if we were to graph it. Okay, so if we were to plot our axes, right, this would be f of x, this would be x. So see how on the right side of the equation, there's no x's in it? That means that it doesn't matter what is along this x-axis. It doesn't matter what x is. The value of f of x is always going to be 1. It's constant. So if we drew a line at 1 right here, right, if this was 1, no matter what x is, f of x is always going to be along that line. Okay, so it's independent of our x value. Okay, so anytime you have a function equaling a constant, that is a polynomial. Because there's nothing weird going on. There's no square roots, there's no rational expressions within the equation. We just have numbers, okay? So that is all right. F of x equals 1, that is a polynomial function. Okay, let's move on to this red one right here. Y equals x squared minus 3x squared plus 4. So we can simplify this, right? We get x squared minus 3x squared. If we have 1 of something and we take away 3 of that thing, that means we have negative 2x squared plus 4. Okay, so I always like to do that just to make it a bit simpler. So this is the same thing as what we started with. Is that a polynomial function? Well, we have to ask ourselves, are the exponents in the variable positive whole numbers? Well, the only term with an x in it is negative 2x squared, and 2, our exponent, is a positive whole number. Okay, so this is going to be a polynomial equation. Okay, I'll just clean that up a bit. So now let's move on to this one here. So y equals 2x squared plus 5 over x minus 11. Okay, so at the beginning of this video, I mentioned that anytime you have your variable on the bottom of a fraction, that's a rational equation, and that's not a polynomial equation. Okay, so even though 5 is a polynomial itself, and x is a polynomial itself, when we're dividing a polynomial by a polynomial in an equation, the equation is no longer a polynomial equation. Okay, it's a rational equation. So this is not going to be a polynomial. Okay, let's move on to this last one here. Okay, so we got f of x, right, our function, that equals x squared divided by 2 plus x. Okay, let's think here. So we know x squared is a polynomial itself because we have x, our variable, being raised to a positive whole number. Okay, and same thing on the bottom. 2 plus x is also a polynomial because 2 is just a constant, that's all good. And we're adding x to the power of this imaginary 1 there. So the top and the bottom, the numerator and the denominator on their own are both polynomials, but anytime we're dividing a polynomial by a polynomial, it's now a rational expression. So this function right here is not a polynomial equation. Okay, so a rule that might help you out is polynomials also can only they can only add, subtract, or multiply with other terms. So see how this polynomial over here, there's a minus sign here and a plus sign there. That's all good. See how for this polynomial here, there was only this one, so it wasn't really interacting with any other numbers, so we're just going to leave that. But another example might be y equals 5x cubed minus 6, and then all of that is times 3. Okay, so 5x cubed, that's a polynomial right there, minus 6, so that minus between the 5x cubed and the 6 is good for polynomials because we know we just can't divide them. And this times 3 here, that's also good because we're not dividing anything. But let's say we were to divide this by, say, 3x. Now we have a polynomial here divided by a polynomial here. Quotient of polynomials is a rational expression. So that is not a polynomial there. Okay, so I hope this gave you some intuition into what polynomials are, how we can identify them, how we can use some of our rules to see if something is a polynomial or not. And I'm really going to be expanding off of this idea of polynomials in future videos. So hope this was helpful, and I'll see you in my next one.